let's talk a little bit about, like, if I'm an account executive and I'm watching this, why do I care about Insight Controls? What can it do for me? And we've got one of your panels right here, which we'll give some zoom ins on later. But so this right here is an Insight Controls product, this whole piece right here.
Yeah, this is a perforated design. Correct.
High-tech facility, temperature and humidity is critical, building pressure is critical. So when do you take from a configurable standard controller to something like this? What are some of the other applications we provide these controls on? I know you've done a ton of grow rooms.
Yeah, indoor agriculture is big. Natatoriums are huge for us. We do a lot of large-scale hospitality, right? And even just some hospitality, hallway pressurization for units, right? Even for some of the hotel chains that we work on, they get a level of custom controls. This is kind of our Maserati of controls, Viking.
Right. So we're here at an AonD Cabinet.
Correct.
But we can do our controls on any unit.
We have a design
You're
for
just
any
out there in
unit.
a custom air handling unit job. You can work with pumps. Competitive products stay on.
Absolutely.
Okay.
Absolutely.
Gotcha. Okay. Hey, everybody. Tony Mormino, the marketing guy for Insight Partners and Hobbs and Associates. And I'm here with Kirk Patton, GM of our Insight Controls. And we're going to talk about Insight Controls and what they can do for you. Before we do that, I wanted to welcome all of our family of brands. So Insight Partners, Hobbs and Associates, and Job, CG Wood, TKO, Eteros, Clima New York, Clima New Jersey, Bay Associates, ETS, EBS, and I think that's everybody.
I think that's
okay. Great, I got it. Anyway, so we're out here at this job. We really wanted to take this opportunity to introduce Insight Controls to you and show you what it can do for you. So I've got Kirk Patton, the general manager of Insight Controls. Kirk and I have known each other for a while. We've done a lot of videos with Kirk, and he's here to kind of tell us and tell me a little bit about what he can do for all the brands for Insight Controls, right? So all of our family of brands have access to Insight Controls.
That's correct, yeah.
Right, and custom controls primarily. Is that accurate statement or?
Yeah, primarily custom controls. Mainly, we're a little different than the traditional controls contractor, right? We focus a little more on unitary controls and not, we do BAS, we do lighting and things like that, but our main bread and butter is exactly what we're looking at today, is a unitary controller to satisfy a sequence for an engineer.
Right, and so Insight Controls started with Insight Partners, but you are nationwide as far as where you do controls, correct?
Correct, we do nationwide.
I think last we counted 26 states or?
Yeah, I think we're up to about 30 right now, plus we have projects in Canada and Mexico that we've been doing for years.
So geography is not a limitation to where we can go with
No, if you can find me an island, just send me. I'll take care of it personally.
You need a videographer for that job, I think.
I do,
too.
Tony, I do.
Awesome. Yeah, so let's talk a little bit about, like, if I'm an account executive and I'm watching this, why do I care about Insight Controls? What can it do for me? And we've got one of your panels right here, which we'll give some zoom ins on later. But so this right here is an Insight Controls product, this whole piece right here.
Yeah, this is a perforated design that we build and fully test out in our Charlotte office. It's designed by our team, purchased, assembled, and tested by our team. This project's been in the works for like a year and a half. The new design with AON is a little bit smaller, but AON also now leaves a spot for us in here. It's a special spot.
Right.
But you can drop it in there so that we have a specific spot to mount the controller now instead of it being on the door.
Right. So we're here at an AonD Cabinet.
Correct.
But we can do our controls on any unit.
We have a design
You're
for
just
any
out there in
unit.
a custom air handling unit job. You can work with pumps. Competitive products stay on.
Absolutely.
Okay.
Absolutely.
Gotcha.
This is one of our higher level designs. We call this our mission critical. It has a UPS battery backup that'll keep the controller and all the sensors live for 20 minutes without power before it powers itself down. We have isolation relays for both power to our sensors and then power for our relays. We have a 66 IO count, and it's actually fully used on this job.
Wow.
Due to the ERU and the number of sensors and data points that they want. On this one, we actually even had to expand the RS-485, so we had to add additional backnet communication.
Just for the number of points.
Just for the number of stuff we were pulling in, so we didn't bog down any networks. And again, this is delivered, we call it kind of a big thermostat, right? You put 120 volts into the corner. You do all your landing right here, which we print all the labels custom for the unit.
Right.
And you're done. So that's all you have to do. It's fully programmed and tested when it ships out. And then, we add an Ethernet switch, so if we ever have to, we can plug in a cellular modem or something so that we can remote access the project.
So we'll talk in generalities for this project because it's kind of confidential, but it's a manufacturing facility, high-tech facility, temperature and humidity is critical, building pressure is critical. So when do you take from a configurable standard controller to something like this? This is obviously a great application for it, right?
Absolutely.
What are some of the other applications we provide these controls on? I know you've done a ton of grow rooms.
Yeah. Indoor agriculture is big. Natatoriums are huge for us. We do a lot of large scale hospitality, right? And even just some hospitality hallway pressurization for units, right? Even for some of the hotel chains that we work on, they get a level of custom controls. This is kind of our Maserati of controls, Vicon, Jace 8000.
Right.
Changing over to the 9000 currently as we speak, is the highest level controller we sell. It's, which is why it's the most expensive. So we do have other brands that we offer,
right,
that give us the ability to hit the right price point, right, but still deliver what's needed.
Depending on what the application is. So for hospitality application, we may have something that's fully programmable, but it might not be as high cost because you don't need to,
you don't need something that does everything.
Right. So we have different tiers of options for controls.
Correct. And so that's where we start. So when we get engaged by our AEs, right, and they come up and they ask us about a project, they give us usually a spec sheet, or they give us some design criteria or the intent, right? What's the intent from the engineer? If they give us that, then we can start designing a system, right? And sometimes, honestly, we've kicked back and said that the configurable controls will work. Wattmaster, where Wattmaster fits, it's a great fit.
Use it, right?
Yeah, we'll push you towards it. We don't, don't spend the money if you don't have to. But then once it does become something that configurable can't handle, that you do need programmable controls or something custom, then we evaluate what you need, how it needs to be done, and then that kind of leads us towards the right controller, right? Because, well, this is the Maserati and costs the most. I'm sure it will do it, but if I can put you in a controller that costs 60% of this, isn't that a better solution? Right? You got the price point, but you're delivering what you need.
You want to be on the job that you need to be on.
Correct.
Nice. So I noticed that inside the unit here, and again, this is AonD specific, there are still some control boards in here. So these are very specific to a particular application in the unit, but we just interface with those. Is that correct? And that pretty common for a big package DX type of equipment, or?
It is. So, we still use AonD's modulating hot gas reheat board. This one has, head pressure control modules because it's, our water, condenser, but we still use them. They still integrate. However, we send them set points. We reset variables. So when the reheat valve is looking for what set point to control to, we're actually passing that information into it.
Gotcha.
So there's still some isolation, some protection on those. What's more difficult things to control.
Right. And these boards know how to do it. They're
correct. Yeah.
Configurable. They're
designed to be standalone. Yeah, absolutely.
Exactly.
So they're standalone with some input from us.
Gotcha.
Yeah.
Now this remote monitoring, can you talk a little bit about that, the capabilities here? I know that's huge,
it's huge.
Very important when you have a critical application like a facility or high-tech manufacturing or whatever. So
so we have two things we'll talk about. We have remote monitoring and we have remote access. Any job sold with custom controls from us at Insight will come with some level of remote monitoring to start, which what that means is we'll provide cellular access or some access so that me and my team can see it remotely.
Right.
Check on it regular intervals to make sure A, unit's working correctly, B, we're delivering the sequence to the design that it was, and then we're logging data to validate that, right? So it's kind of like a pre-commissioning before commissioning, right? We can see that it's holding the way it wants. Once all that's done and it's up and running, you're not having issues, you're through commissioning. At that point, we usually recommend going to what we call remote access. It's very similar, right? We have some sort of cellular modem, but we're not looking at it regularly because we've validated it. We've watched it through its seasons. We know that it runs correctly as designed. But then when you do have an issue, when there's a problem or if a technician's going to site, we have access to assist.
That's so nice.
Now, in this one too, specifically, I know it's not powered up right now, but this 7-inch display will give you full access into this controller from the unit. So you actually don't even have to come up here with the laptop. You can come up, use your login credentials. You'll see the graphics. You'll see the set points. You'll see any alarms or issues you're having based on how we designed the program.
Now, this panel is in a unit, but you can get, I saw you make them in big sheet metal boxes. You can put it indoors. You can put it on the side of a unit. You can put it pretty much anywhere, correct?
Yeah, we can. So with AonD, we try to keep it internal to the unit. Like I said, that's why we work with AonD to get a spa.
Yeah.
But when we get into custom air handlers or other manufacturers, whether we're talking Miller Picking, Nortec, or like an Annex Air, when you get into those, they don't have the footprint inside. So we'll design a closure. It'll be UL listed, right? We'll have it manufactured and mounted, and it'll all be housed based on our design and with all of our components.
Great.
Yeah.
Okay. Well, anything else you need to cover?
I think that covers quite a bit.
How do the folks get a hold of you?
Well, there's a couple of easy ways. The first one is email, right? So it's controls@insightUSA.com. And you can always call our 877 number, which sound familiar to some of you, but it's 877-875-2524, and just kind of leave a voicemail, because I promise you nobody's answering.
By design.
By design. It is designed that way.
Yeah.
So it's designed, it hits an email distribution list, and then somebody from the team picks it up. So that's really the easiest way to get in touch with us.
So, yep. Sorry, I cut you off there.
No,
So
you're good.
AE wants to price a job. They get with you, talk about the job. You ask a bunch of questions.
Yep.
You get a feel for it. You give them a price, points list sequence if they need it.
Yep.
Drawing. They get it specified. They price it out, and then they're good to go. That's kind of how the process works.
Yeah, it's pretty similar. Usually the first step is a phone call from an AE, and it ends up being about a 15, 20-minute conversation.
Right.
And we're trying to qualify if you really need custom controls, right? Because, again, we don't want you to spend money you don't need to.
Right.
And so we try to qualify that. And then at that time, if we feel like, hey, it's leaning that direction, we just recap what information we need.
Yeah.
You get it to us, we review it, and then whether you need a budget number or a hard number, we work that out.
Awesome.
Yeah.
Great. Thank you, Kirk.
Awesome.
And
Thanks,
thank you,
Tony.
Jon Stevens, our cameraman there. We appreciate you. All right, so we're going to do a quick AON unit walkthrough. So this is an AonD cabinet. So we don't have airflow monitors on here, do we, Kirk?
We do. They're not installed yet.
They're not installed yet. Okay, so
There's
this
one system over there that has it.
one system over here. Okay, so this, just from an overall view, I don't know if you can get an overall shot. Watch behind you there, Kirk. R&D 50?
These are 50-ton.
50-ton unit, package DX unit, and you'll notice something very different about the unit. If you can give a good pan over here, there's no condenser coil. So these are water cooled, actually water source heat pumps, ground loop cooled, I believe, if I'm not mistaken. So the other unique thing about these units is they have exhaust fans with VFDs and energy recovery. So this is your standard AON energy recovery wheel pie kind of shape. I wish I could pull this out, but I don't want to get into all that. But anyway, energy recovery wheel. I don't know if you could come around here, Kirk. You can probably see a little bit in here. And I've got Jon Stevens here. He's going to tell us, what do we have on controls here, Jon?
So basic controls, we're trying to see how much energy we are saving by utilizing the energy recovery wheels. So we're taking temperature and humidity readings before and after the outside air intake of the systems. And we're taking temperature and humidity on the return
On
and
the return
exhaust
side.
Yep.
So we've got, just so I didn't do a good job of explaining this. So the return comes through here,
Yep.
comes up. Let's pull this open here. Kirk, what'd you leave this here for?
Yeah.
Didn't you know it's in our way? So return air coming up through here.
Yep.
Into the damper assembly. Outdoor air is coming across here. It might be a little hard to see with that video, but there's isolated damper banks, right? Like, so this is the OA damper with these three here, I believe. And then,
So this would be your mixing chamber where your return air and outside air is going to mix before going into the evaporating
this
section.
part right here, right? So exhaust return air is coming up through here, going through the wheel, which is separated by this plate here. Okay. And it's exhausting out. So this relatively cool and dry on a summer day compared to this very hot and very wet air. So the energy recovery wheel takes the energy and moves it around. Okay. It pre-cools and lowers the humidity. I hate to use the word dehumidifies, but lowers the humidity content of the outside air. So continue with the sensors. I'm sorry. I totally shut you off there,
the
but-
energy recovery side, like we said, we'll see the return air systems, the exhaust air systems, outside air conditions, and then post energy wheel delivered to our
That's nice.
air mixing chamber, going into the actual cooling section and heating section of the equipment. We do have differential pressures to monitor filters. So we have outside air pre-filters. We do not measure the differential pressure on the wheel. And then post wheel, final filters will be monitoring the exhaust return. And then to the final piece, when they put the exhaust dampers out here, we'll be monitoring the exhaust duct static.
That's nice.
To be able to control space pressurization with that.
the exhaust fan.
Yep.
Yeah, so it's rare when we do a package DX unit, we have this type of sensors in the unit, right?
Yep.
So like usually we're not measuring, and I think we're measuring temp and humidity here
Yep, correct.
and here
Yep.
and here, but just temp here. Is that right? No temp and humidity
Just temp on the exhaust.
on the exhaust. That makes sense.
Yep.
Gotcha. So cool. So the exhaust fan is over here. So this is a belt drive fan, plenum fan, VI plenum fan, but it does have a VFD in the front cabinet. We'll look at that here in a minute. So metal mesh filters for the OA, which do actually a surprisingly good job at catching a lot of stuff.
They will have airflow monitoring right here. They'll do a velocity calculation, and there'll be a transducer up in the front of the systems with our controls, so they'll be able to do outside air calculations for airflow.
Very nice. All right. So also while we're here, MGM curb, vibration isolation curb. So we do a lot of these, located right here in Georgia, if I'm not mistaken. Okay. So let's see here. So as we go around, so we talked about, I wonder if we get to this on the other side. Are the doors in there?
Both sides, yeah.
All right, why don't we go to the other side so we can...
I can probably move that.
No, that's okay.
Actually, we're good because there's sensors over there.
Mixed air.
Yeah,
We're leaving reheat coil. Here's your, water piping coming up too.
So that's the what. So this is the... So this is a staggered DX coil.
correct. Yeah.
Right? So this is the bottom coil.
Yeah.
And this top coil is actually back here. Oops. There we go. This is the filter bank for the top coil, right?
Yep. That's
And
your
the bottom
final
coil's down
filters.
there. And the reason we do that is so we can get more
surface
airflow and surface area through the coil. So explain to me what's going on with the piping there, John?
So right here you'll have your condensing water loop coming up to the water-cooled condenser on the top of the system. As he just talked about, going through the 2 stages of cooling, you have your final reheat coil, and then we do a mixed air temperature reading to see what the discharge off the actual reheat coil is before any heat gain or anything like that going discharge down to the supply ducts of the system.
That's nice.
So this is just roughed in right now. This will be attached, these 2 attachments up here.
Oh, okay.
Water
Gotcha.
condenser, valves, everything is internal to the top of this system, controlled by all of those control boards up in the front, which we send set points and values to. So you're controlling your head pressure here, refrigerant flows, monitoring your discharge air temperature, and then we'll ultimately be reading the temperature and humidity off the discharge of the system.
Great. So for those watching, explain what that big microchannel coil is sitting there.
So this is the hot gas reheat of the system. Is this a tandem circuit? 2-stage reheat? This is a single stage. Single stage, right?
No, it's 2-stage.
Okay. So it'll be a 2-stage hot gas reheat. So as we're going through the dehumidification, saturating all of the air through the cooling coil, this will be our single stage reheat coil. So we'll be using hot gas discharge off of the compressors. Energy consumption savings, along with utilizing the ability to reheat the air before we discharge it down into
awesome.
To get that full psychrometrics feel out of the dehumidification.
I love that.
Sensible side delivering
Psychrometrics
to the air.
feel. That could be our tagline, the full psychrometric experience.
Yeah.
But so we do a ton of AonD products, and I would say the majority of them have hot gas reheat on there for that purpose.
Especially applications like this, low dew points where we're trying to have a
Critical manufacturing,
critical
low dew
manufacturing,
point.
and the sensitive air control, being able to control not only the dehumidification but also the sensible side of it as we deliver it down to the spaces.
Excellent. Okay, so what's in this section? Let me guess.
Yep. So here's our fan section. These D boxes have a single fan in there. They are driven by a VFD up in the control cabinet. So this application is a little different than a typical just single system air volume. All 6 systems will work in unison to control a single duct static pressure control. So they will all have a common control variable between the systems to calculate the duct static pressure. As one system comes up, they all come up. As one system goes down, they all go down to maintain that constant duct static.
So there's 6 package units, identical, pretty much?
Yep.
And they're all feeding a common supply duct?
Yep, correct.
And there's one pressure somewhere, or is it like an averaging type scenario? Or?
Currently, they all have a duct static, and we'll take an average of the 6 total to create one single point to control all 6.
And this will modulate. And this says, so people who are watching who don't know, this is what's called a direct drive, because there's no belt.
Yep.
Plenum fan. It's a BI plenum fan. That has to do with the way the blades are shaped. And the air is coming from this way, going over the motor and blowing down into the supply plenum here.
Yeah.
But this is kind of a unique application because of the fact that they're all kind of operating in unison there. So.
Yep. So we do have one safety feature inside of here. We take the pressure of the fan cavity, and then there is a high static pressure switch. So if anything happens downstream of the system, a damper collapses, a damper closes, something along those lines, it'll sense the high static in the system.
So it doesn't blow the duct out?
Yep. Or blow the system up here up. If anything below the system turns off or closes and the pressure up here exceeds 2 inches or 4 inches, whatever the design was, that high static will trip and turn the fans off.
Yeah. Blowing the ductwork out's not a lot of fun.
No.
I've not seen that happen personally, but thank goodness.
Yeah.
Anything else on the fans? Or
we do have a nice service light in here. Aon always thinks about the technicians in these aspects. So if you're out here working at nighttime, replacing a fan motor or doing any kind of work, you do have the accessory of a nice light in here to give you some seeing light. So
very nice.
Some vibration isolation.
Very nice.
But
I love these fans. They're my favorite.
Easiest to work on.
Easiest to work on. No belts.
All right, you want to hit on sensors in the electrical cabinet, CTs, stuff like that?
Yeah.
Yeah. So one of the things to point out is we talked about hot gas reheat. These are the 3-way hot gas reheat valves.
Right.
And, we get a lot of questions on that, so I'll just go over that real quick. So the discharge of the compressor would normally reject the heat to the atmosphere if you had a condenser coil on here. In this case, it would normally reject the heat to the coaxial water-cooled condenser, which is ground source water supplied. And that's what we do here, but when we need the reheat, it diverts the 3-way valve. 3-way modulating hot gas reheat valve diverts the gas to the hot gas reheat coil that we looked at before when we need the reheat. So it's really nice because you can modulate that and really nail the leaving air temperature as opposed to, on-off reheat, which we don't see that very much anymore. That used to be kind of a standard, and modulating was this really super premium deal, but it's pretty common for most, highly configurable unit manufacturers. So anyway, back to the controls. So we have some CTs in here we're going to look at? Or?
Yeah, so the VFDs, every motor that we have in here is based on a VFD. So starting from right here, this is the supply fan VFD. So this will be controlling the motor for the supply fan about the duct static ramping up and ramping down. We do get motor feedback from these, so we can see a percentage demand of what the fan is actually putting out.
That's what this is right here?
And then that is a CT, so when we can monitor the on and off power consumption of the
feedback
the
comes through the drive, and this is just the power.
Yep.
Gotcha.
Yep, correct.
Gotcha. Why is this important to have?
We use that basically as a confirmed on-off feature of the fan. So even though we're getting the feedback from the fan, that shroud could have came off, the blades could have came off, and that fan's still sitting there running.
But it's not pulling any draw. So if it's not, then we know it's not.
Yep, correct.
So there's something going on that's wrong.
We call it a proof of flow. We know that the energy is going to the fan motor. The VFD's proven that. We'll see the duct static react to that contact closure. We'll be able to verify that the fan is turning on.
Right, because we're calling for a component to run doesn't mean it's actually running, right?
Yep. Yeah. And we use that same CT for all of our compressors. So we've got one on every load side coming off of the main contactors to verify that we have compressors turning on and turning off when our controls are telling them to. We do have phase and brownout monitoring on these systems, so we can monitor if they have a phase loss, a brownout, high voltage, low voltage. We try and keep those pretty standard with parameters set by the VFD manufacturers, so we don't go over voltage or under voltage. Try and protect our motors all to the best aspect that we can.
Nice.
Over here, we do have a VFD on the heat wheel for these systems, so we can drive them up and down based on our energy consumption and what kind of load we're trying to be able to save off of those energy recovery wheels. This will be the exhaust fan VFD. That will be controlling our exhaust duct static or space pressure control. Again, another variable VFD. This was the high pressure switch that we were talking about. If anything exceeds whatever the set point, I believe at this project it's somewhere around the 4-inch range.
Gotcha.
That'll be the
just
automatic
another
reset.
safety.
Yep.
Just to make sure.
Make sure we don't
Nice.
blow any ductwork apart. So everything does come back to our inputs, so we can read all of our sensors that are installed. The DLPs that you see here, those are for the filter monitoring, taking the differential pressure from the high and the low side of the filters. You can set an alarm up in a trend to see when it's time to change filters, different seasonal changes, pollen season, all that kind of stuff. So every 3 months might change to 1 month during a high pollen season. Sometimes in a dry summer, it might change out to 4 months. So you can monitor that differential pressure and be able to know when it's time to change filters.
Excellent.
So,
cool.
yeah, that should be all the sensors in the controls cabinet. So
Great. Jon Stevens, Insight Controls. Thank you very much.
Absolutely, Tony.
And thank you,
Thank you.
Kirk, for being the cameraman there. Appreciate you.